Okay, in this problem, you're asked simply to divide using long division. If you're thinking, well, I don't like long division, I'm going to use synthetic division, please keep in mind synthetic division isn't going to work here if you have a degree bigger than 1, and we do here with x squared. So, unfortunately, there is no way around this. The steps for using long division are the same as when you first learned long division back in elementary school, and that is this. Dead mice smell bad. Okay, maybe that isn't the secret to this, but essentially this tells you the order of the steps that you're going to use, in that you would first divide, then multiply, then subtract, then bring down. Let's first divide. When you're dividing, you compare first term into first term. So x cubed divided by x squared, and that gives us x. Let's go ahead and write that answer up here. Quick question for you, where does it go? Well, you want to place it over the term that has an x because these are like terms. So you always want to be conscious of which terms are alike, so that way you can always line them up. Okay, next step is to multiply, and what you're going to do is you're going to multiply this answer here to the entire divisor. It's a good idea, by the way, to do this work on the side. So when you're multiplying, you're simply just using distributive property. So you wind up with x times x squared, and then x times negative 7. And you wind up with x cubed minus 7x. Let's go ahead and write that underneath. Again, keeping the same theme here of keeping the like terms together. X cubed goes under x cubed, and negative 7 does not go here because these are not like terms. So you'll put it here instead. Okay, let's go ahead and subtract. When you subtract, you're subtracting the whole thing, which basically means you're doing this. Now, if you simply write it out like that, you're probably going to make some mistakes. It happens often to students when they just simply write it like this. Therefore, the way you'll want to approach it is you'll just simply want to flip the signs and then do your subtraction. Now, if you do this successfully, you'll wind up with just negative x. Strike that, make that x. Okay, now let's go ahead and bring down the other terms. Notice that the negative 3x squared was not involved in this last operation, so it got brought down. Same thing with the negative 1. And then from here, we start the process over again. And that is, we'll divide. Now when you divide, you're doing first term again into first term, except you're not looking up here anymore, you're looking down here. So the first term is negative 3x squared. So right here, negative 3x squared divided by x squared, I'm writing the work on the side. The x squareds essentially reduce out, and that leaves us with negative 3. Let's go ahead and write that answer up top. And then again, we're going to multiply. So take your negative 3 and times it to the entire divisor, that's x squared minus 7. Remember, that's essentially just distributive property. So when you distribute negative 3 to both terms here, we wind up with negative 3x squared plus 21. Just as before, we want to kind of line them up under the correct terms. So negative 3x squared goes under the x squared term. 21 goes under the constant. And now we can go ahead and subtract. Again, keep in mind that when you're subtracting, you're just essentially changing your signs. So that becomes negative 21. That's a positive 3x squared. And we get x minus 22. We'd bring down, except there's nothing left to bring down. So then what we do is we again start the process over again. So divide, first term into first term. However, make a note, x divided by x squared. You see that the degree up here, up top, is smaller? If that's the case, that means you can't go any farther and you're done. Therefore, that's going to be your remainder, and that's going to be your quotient. You'll get a little bit of debate on this. There will be those who will think that the quotient is x minus 3, and then what they'll want to do is they'll want to tack on the x minus 22 and put that over what you originally divided by, which was x squared minus 7. Some textbooks will have it one way, other textbooks will have it the other way. For our purposes, this is good enough. Okay, write in standard form. What we mean by that is this. Your answer is going to have two parts, a real part and an imaginary part. Here's what you don't do. You don't take this over this and then these two and then write them as two separate fractions. This is a very common error that a lot of students will commit, and if any teacher were to see that, you'd be immediately marked incorrect. Nor do you want to take this entire numerator and then set it over 1, and then do the same thing and put it over 3i. We can't do that with a denominator. You can't separate like this, because if you were to try to put them back, you would need to get a common denominator first. That would mean multiplying this one by 3i top and bottom, and we'd wind up with a very different result at the very end. So that doesn't work either. Instead, what you'll want to do is you'll want to multiply the top and the bottom by the complex conjugate. And it's going to be the complex conjugate of the denominator. The main idea is we want to eliminate this I down here. Now the complex conjugate essentially is going to be the same statement with one change. The sign in the middle here is going to be opposite. Okay, so you want to go ahead and multiply these together. Multiply the top here, and you get this. And that just comes from doing first, outer, inner, last. Now on the bottom you can also do first, outer, inner, last. However, if you're doing that, you're not recognizing why we use the conjugate. What you're doing is you're creating the difference of two squares. Remember, the difference of two perfect squares simply means this. If you have a situation where you have the same term twice, right? You have x and 5 and 5 in this case. Only one's positive and the other is negative. Then the result would be just simply for you to square each of these two terms. In other words, the middle term would simply go away as a result of cancellation. That's what you're doing here. You're eliminating the middle terms. And we want to do that because in order to write this in standard form, we again need to get rid of the I. So square the 1, you get 1 squared. And then square the 3i and you get 3 squared I squared, minus sign in the middle. And because a positive times a negative is negative. Now keep in mind what I squared is. That's negative 1. You might also see it right here. So taking that into account, that's 12 times negative 1, which is negative 12. Here you're kind of seeing the same phenomenon. 3 squared is 9, and I squared is negative 1. So if you collect all your like terms up top, negative 4i, negative 6i is negative 10i. 2 and negative 12 gives you negative 10. And then the denominator here just gives you positive 10. And lo and behold, there is no i's down here. Now, we can separate this numerator into two different fractions. You can do that with numerators. You can't do it with denominators. So let's go ahead and do that. And you wind up with negative 10 over 10, and then negative 10i over 10. And then just go ahead and reduce those fractions. And that finishes that one. Okay, for this one, what we're going to try and do is we're going to try and determine this unknown coefficient here. Now, to do that, we're going to have to use this bit of information here, the fact that x plus 2 is a factor. And what that means is that if you were to take this and divide into this polynomial, you'd get a 0 remainder. That also means this. This means that negative 2 is one of the zeros, one of the x-intercepts. So if you were to take negative 2 and plug it in for x, you'd get 0. So let's use that information. Why don't we take negative 2 and why don't we plug that in to the equation? So that's what we get. And by the way, since it equals 0, just put equals 0 at the end. And if you'd like, you can take that first part off to help avoid any confusion. Now what you get here really is just a simple equation after that. Just go ahead and simplify this part. Collect your terms, and then from here add 5, divide by 4. And that's it. That's it for this one. I'll see you next time.